An introduction to limits. Limit of a function is the value that a function of x gets closer to as x approaches some number. The example 1, find the limits of limit 4 over 3x minus 4 when x approaches 6. First of all, let's look at the graph of function of x equal to 4 over 3x minus 4 and examine points where x is close to x equal to 6. We will start with points where x is less than 6. Notice that as the x values gets closer to 6, the function values appear to get closer to y equal to x. Now, let's look at points on the function where x is larger than 6. As before, the closer we got to x equal to 6, the closer the function got to y equal to 4. Therefore, the answer to example 1 would be written like this. The limit of 4 over 3x minus 4 as x approaches 6 is equal to 4. Limit notation. Mathematicians have a special notation to indicate they are working with limit values. The LIM tells us we are looking for a limit value, not a function value. X approaches a tells us what the variable is and what it is approaching. Function of x tells us which function we are working with. L is the value of the function is approaching. Limit of a function. When we write limit function of x when x approaches a, we are indicating that x is approaching a from both sides. If we want to be specific about the side from which the x values approach the value a, we use the notation. These are called left-hand and right-hand limits respectively. In order for a limit to exist, both the left-hand and right-hand limits must exist and be the same. This leads to the following theorem. Limit theorem. As x approaches a, the limit of function x is L. If the limit from the left exists and the limit from the right exists, and both limits are L, that is written like this. Here is an example of left and right hand limits. Techniques for calculating limits. There are 3 common ways to calculate the limit, including the graphical method, table value, and find it algebraically. Find limit x squared minus 3x plus 4 when x approaches 1. With the graphical method, solution or from a graph of function of x, we see that limit x squared minus 3x plus 4 when x approaches 1 is equal to 2. In this example, the left hand and right hand limits approach the same value, which is 2. The second method is table value. Algebraic way. First, we use direct substitution to evaluate the limits. 1 power 2 minus 3 times 1 plus 4 equals to 2. In some cases, direct substitution produces infinity and negative infinity in both the numerators and denominator. It is called an indeterminate form. Therefore, we have to use dividing out techniques and rationalizing techniques to solve this kind of problem. Limits typically fail to exist for one of three reasons. First, the left-hand limits are not equal to the right-hand limits. In the graph, we notice that limit function of x when x approaches 3 from the left is approximately 2, and when limit function of x when x approaches 3 from the right is approximately 3. Therefore, the limit doesn't exist. Second, the function doesn't approach a finite value. In order for a limit to exist, the function has to approach a particular value, in the case shown above. The arrows on the function indicate that the function becomes infinitely large. Since the function doesn't approach a particular value, the limit does not exist. The function doesn't approach a particular value, oscillation. The closer x value gets to 0, the faster the function oscillates between 1 and -1. Is function of x approaching a single particular value? No, it isn't. Consequently, the limit does not exist.